Straighten, and this is my video for the multi-threaded programming and IPC project for operating systems. As you can see, I've got Ubuntu set up here on my VM workstation, and let's go ahead and get the terminals going so you can see the output. Alright, so first thing I'm going to want to do is run a pipe thread. Whoops. Let's do .NET run, and we should see waiting for connection ... Pipe thread is my IPC program that is going to print out all of the information from my threads, which will say which resources it's accessing and when it's releasing them. So now that we've got that connection going, let's create a new window of terminal. And this time we're going to run OS project threading. And .NET run. And you might see when you run it that, it's stopping right now. That's because some threads are sleeping. That's how I did the timeout mechanisms. So threads 11 and 12 will sleep. And then after that, the main program will sleep before it sends all of this information to pipe thread. So let's go ahead and take a look at pipe thread so we can see all of that thread information. Perfect. So we can see that thread 1 accessed account 1 savings and then it released it, and then thread 2, you can see all of this. Let's pull up. So threads 11 and 12 did not send to pipe thread because when I decided to use IPC to send that thread information, I thought how I wanted to do it, and then I ended up they all write to a string, concatenate a string, and threads 11 and 12 are supposed to enter deadlock to showcase the timeout mechanism and deadlock recovery. And because I had this one string that 10 threads are trying to access, I implemented it with a mutex to protect it. But of course, if I have a mutex and threads 11 and 12 have to wait for that mutex, they will never actually enter this deadlock state. So that's why that's what it outputs here. So right here we can see that thread 11 acquired account 1 savings, thread 12 acquired account 2, and then they're both going to try to acquire the other one. So you'll see, thread 11 could not access account 2 savings, sleeping and trying again. And then same thing for thread 12. And then it'll try one more time to access that. And if it can't, it will release its hold on account 1 savings, because this is thread 11. And then it will close the thread. So that allows thread 12 to come in and get that thread. So you might have noticed that we have 1 through 6 and then 9, 10, and then the other one is 11, 12. So what happened to threads 7 and 8? So let's go ahead and pull this up. So threads 7 and 8 are to showcase how deadlock occurs. I didn't implement the prevention afterwards for them because that's what threads 11 and 12 are for. So thread 7 will lock account 1 and then it'll try to lock account 2 but never releasing. And thread 8 will do the same thing, but vice versa. Threads 9 and 10 show how to prevent deadlock by, releasing the resource before requesting another one. And 11 and 12 I just explained. 1 through 6 use a lot of mutexes. 9 and 10, of course, also use mutexes because they are using this thread info string to keep up all that information. And that's about it, really. Thanks for watching.